So across here we have stretched a ferrous metal wire, ferrous meaning that it is or has partially iron in it. This is specifically steel wire, but for our intents and purposes, that does not matter. So it has iron in it, which is why these magnets are currently sticking to it. This is something called a variac. So this lets me control the voltage of electricity that is traveling through this wire. And we are about ready. Oh, what is it?
How much damage does it cause if you turn it on and you touch it?
We're not gonna touch it. Let's put it that way.
I already burnt myself yesterday. Might as well let it out on the damage.
Alright, so I have now plugged in the variac, and we now no longer want to touch anything in this arrangement. So I am about ready to turn this up. I am turning it up to 30 volts. Okay, that is not steam, that is smoke. The reason that it smokes is because we have oil covering these wires because ferrous wires want to rust. I'm going to turn it up just a tad bit more. And we can see that the whole arrangement is sagging.
Oh, you can see like a little, you know, like when it's hot outside, you can see like a little heat waves.
Uh-huh. So yes, this is getting very hot. That's the reason that, the primary reason, or the reason that it's getting hot. Why would it get hot and a copper wire would not? You can coat a copper wire in plastic to insulate it with the electricity. But if you insulated iron wire with plastic, it would melt or more likely burn your plastic. So why would that happen?
Because it's more.
Can it get warmer than the copper
Because
wire?
it will get much warmer. Which one's more conductive?
No, copper wire is.
Copper wire is more conductive. So this is resisting the passage of the electricity through it. So it is picking up heat energy from the electrons that are trying to pass through it as we are sending the voltage through. Thus, it is heating up. And if I go ahead and I turn this off,
Oh, what? What? See, I thought.
it goes back up.
I thought Maddie was going crazy.
So why would that happen? So what? Why does it sag and then it goes back up?
Because the heat allows it to like particles to expand, so it gets like lengthier and it's like
Exactly. So as it's heating up, we have the particles are vibrating more and more, and as they vibrate more and more, they gotta have more room to bounce. So we have this whole wire is expanding, both in diameter, but more distinctly in length. So as it gets longer and we have it between two fixed points, the whole wire sags. Now I'm going to turn this up.
Leave it in.
I'm going to turn it up to 60 volts of alternating current.
Oh my gosh.
And what's happening around the magnets?
it's like not glowing.
It's like,
not glowing.
They're taking the heat away.
oh,
Yes.
it's better
So they're
off
taking
camera.
the heat away. They're acting as heat sinks. Yes,
Can I
Thomas.
touch it?
You don't want to touch this. Who needs
But
Christmas
I
lights?
really want
Why
to
would you
touch
want
it.
to
I
touch it?
really want to touch it. Because it's
Okay.
light.
Okay.
It's not like a glow stick.
Just
It will
add to the
hurt
damage
you.
already.
Hold on. Maddie has a question. Yes?
Is it true that if you're not grounded and you touch something that will shock you, it won't shock you?
If you what?
You know how like, okay, so if you're standing on the ground and you touch something that can shock you, it's gonna shock you. But if you like jump and you touch it, it won't shock you if you're not on the ground.
You need ground.
It
That's my question.
electricity will
entrance,
take
positive
the
ground.
easiest
Negative ground?
possible
Negative.
route to the ground. If you are standing on the ground, you are the easiest possible route to the ground, and you are pretty much made of water, which conducts electricity pretty darn good. If you jump, then it has to pass through you and through the air, which is an insulator, which means it's less likely to shock you, but I still wouldn't recommend you try it.
Okay, I was just wondering.
So, in other words, if there's a thunderstorm outside, to start jumping like Mario and good.
No.
That's right.
Remember, air is an insulator. If it's able to pass through air, it's definitely able to pass through you. Okay, in any case, I'm going to turn this up a little bit higher so that we can get this to happen a little quicker.
I feel happy.
So now we have some serious thermal expansion happening. We have it sagging pretty good.
It's a lightsaber.
And a magnet just dropped off. So why would the magnet drop off?
Sagging too much.
Isn't it because
Got too hot.
Is it losing
offsets
magnetic?
magnetism in the wire, so it no longer has? Is it so hot?
I wouldn't say offset.
The heat is moving through it and it's
Yes, Tom?
It's because it's getting so hot that the molecules in it are spreading out farther and farther, so it's losing less magnetic properties. It sounded smart.
That sounds very sciencey.
Partially. So as the heat increases, the atoms are able to move around, and there goes the other one. And the reason that the magnetic field can interact with the iron is essentially it pulls the electrons to one side, making an attractive force, and you have the magnet attracted to the wire, even though the wire is not in and of itself magnetic. So at this higher temperature, they're more mobile and less able to interact with that field. Yes?
Okay, I have 2 questions again. Why is there a piece of styrofoam?
The styrofoam is just a weight so that it sags better.
Okay. And then how come the wire produces the light that we can see? Like, what's going on?
So at high enough temperatures, materials will emit light. And in fact, it emitting this light is no different than it emitting heat in the first place. After all, both are different kinds of what are called electromagnetic radiation. So electromagnetic radiation in the infrared spectrum, or infrared spectrum I should say, is just heat, what we perceive as radiated heat. Since this has more energy now, it is able to, bless you, it is able to emit in a higher weight, in a shorter, higher energy wavelength that we are able to see with our eyeballs. So this is called incandescence. And with, say, an incandescent light bulb, it is the same process that allows it to light up your room.
Can it get brighter?
Can what?
Can it get brighter?
Can it get brighter? It can probably get brighter. We're not going to take it brighter at the moment. So now I'm going to turn off this, and I want you to watch how it rises back up.
So there's one shot. Got $5. Dang it.
Now Heather can't see it.
Alright, but did you see it was sagging, it rose back up, but then it fell back down again
Yeah.
and rose back up?
Mm-hmm.
Why would that happen?
Getting used to gravity again?
You fooled
Well,
it.
gravity is kind of constant. Witchcraft. What?
there's witchcraft.
Witchcraft. All witchcraft is science, all science is witchcraft, sure.
I have a few different reasons. Theories.
Alright.
Theories.
Not theories until supported by evidence.
I don't know if it's. I don't know if you get it. Anyway.
Okay, Thomas.
So, is it because, again, molecules, is it because they're moving so fast, when you shut it off that fast, it kind of goes through the whole entire motion again and goes back down? Kind of like a, how do you put it? Kind of like a yo-yo action, where you forcefully put it down as fast as you can and it comes back up.
It's 10 minutes long.
It's fine. So there's no string attached, but you are right that we are recompacting our atoms in this. But at some point we end up with them expanding back apart again. Now, do we remember? I'm gonna grab one of these guys.
I love science.
This class is fun.
They choose the balls.
Do you guys remember our different unit cells?
Yes.
Yes.
The face,
So
Simple
we
cubic
have, what is
and
this one?
body,
Body centered cubic.
face
And we
centered.
have
Face center cubic.
face centered cubic with the little smiley faces.
Brian Bader.
So which of these is more tightly packed?
face.
Face center.
Face centered, and then our body center is loose. Now what if I told you that just like sulfur that we worked with before, iron is also allotropic? Do we remember what allotropic means?
No, ma'am.
Isn't it like it's rhombic and
Yeah, so we had the rhombic form of sulfur. What was another one?
monoclinic?
Monoclinic?
Amorphous.
Amorphous.
Who did?
So in the case of iron, these are our two allotropes. We have a body-centered cubic and a face-centered cubic allotrope of iron. Now, does anybody remember how we got, let's say, the amorphous and the monoclinic? What did we do different to them?
Didn't you heat them to different temperatures?
We heated them to different temperatures. So what did we do in this case that might be the same? We heated it to different temperatures. So at higher temperatures, our face center cubic is the stable form of iron. And at lower temperatures, the body centered is the stable form of iron. So now knowing that, what do we think happened partway through the cool down process that made it gain more volume for a second there?
Oh! Is it losing and like adding back on? Because you said it's kind of switches, so is whatever the frick those balls, what are those? The kind of ball things. What are the balls inside of it?
The one with the ball inside of it, we have
Well,
body
what are the balls called?
atoms.
Atoms. Is it because they're losing atoms and getting back?
We're not losing any atoms. There's no atoms going anywhere. They all stay there.
Expanding and then come back together.
Is like the face center cubic and then it transitions to the body center cubic, so that's why it's that.
So we have the transition between the face center cubic. So we have thermal contraction because we are cooling down our wire. So we have the contraction, so it's going back up. But then partway through there, we convert to body center cubic, which is much looser packing of atoms.
I'm not sure how much.
And so it goes back down to then continue the thermal contraction, going back up. Now, I'm going to unplug this real quick so I don't zip-a-zap myself.
Is it still hot?
It will not be hot. I'm gonna check it though. If I come along here and I bend it, does anybody see that there's stuff falling off?
No.
And it sounds kind of crackly?
No?
Is that the rust?
It isn't rust, but what is rust?
Is it rust oxidation?
Oxidation. So this is a different kind of, essentially the same thing that rust is. Rust being
Fe2O3?
This is FeO, also known as scale. So scale forms very quickly when we have the heating of a piece of iron. Rust forms relatively slowly. Now I'm going to go ahead and heat this back up again and see if you can see how many places I bent this in. Oh, I did not plug it back in. Thank you, Paige.
Me.
The only thing I can get right.
Alright, I'm going straight back up to 60. Can you see where I bended it in?
So cool.
That's the Christmas lights.
So it's only lighting up in the areas that you bent it.
Yes.
Christmas lights and you've got copper light.
That's what I'm saying. We just
So
lined them in
why
copper
did
wire
that
and
just
bent it
happen
in
and
the
why is it going away? Or
Because it's
let's
making-
It's just brighter on the camera. It's
We just saw
brighter
it.
where you bent it and like not so bright where you didn't.
Uh-huh.
so you can see it a little bit better.
Because the bends going back just being straight or being odd.
I did straighten it out.
Is that because the
Oxidizing.
FeO is like off of it, and when that comes
Ow.
off of it, or like it gets hotter faster?
20 minutes in?
1540.
Partially. So what is oxidation? Huh? You had thoughts?
It's oxidizing.
It is oxidizing again, so that's why it's turning back. But
Well, I thought I just lost the bumps.
what do we know about
No, that's
oxidized
still
material?
there.
If we take a piece of rust and we hit it on the table, is it going to behave like metal and bend, or it's brittle?
It's
which
just gonna
is the
shatter.
behavior of what kind of material?
Ceramics.
Ceramics. And ceramics behave how with electricity? Nice air 5.
Crap.
Huh?
Crap.
Like crap. They do not conduct electricity well, and they don't conduct heat well either. So for the portion of the wire that we have the oxidation still on, it's not conducting the heat out to the surface, and so we don't see as much glowy as we do with where the metal is showing. And now we have pretty much the whole thing re-oxidized.
Yeah, it's also not an insulator, Maddie.
It all just clicks.
Yay!
Madison just had an aha moment.
Maddie wants to be
I
a scientist.
love aha moments. Okay, so I'm gonna turn this off.
What are you doing?
So to make this hard, I'm going to stress it through repeated heating, cooling to weaken the whole arrangement, and eventually this whole thing is just gonna fall down. It will probably fail at where I cracked it the first time.
That's enough.
If you got muffin
bread, I'll Alright.
send it to you.
I know that was
So let's have some.
Ooh,
Ooh.
it's really bright.
That, oh my god. It
Pretty
kind of
bright.
looks like embers, like in a fire. Fire embers.
It's a tiny fire.
Madison.
Baby
It's lit.
fire.
Let's not have fire in here, please.
How you doing?
Alright.
Really bright wire.
So that's kind of blinding. And so we can see over and over again the conversion between our body centered cubic, or face centered cubic and body centered cubic, if I can keep track of which side is right and left.
That's getting really, really bright now. Like it's blurring out the camera.
We're just here to blind you more.
I mean, I've got my.
There we
Whoa!
go.
What was that laugh? It sounded like
Alright, so repeated heating and cooling will result in excessive stressing of the wire, and
And scaring of a Heather.
Unplug it first.
yes, unplug it, but we now have no connection between this side of the circuit and this side of the circuit, resulting in it being an open circuit, which does not allow the traveling of the electricity through it. And Ian, if you could get the front light, so the light panel that's in the front there, we're gonna check out both of them.
Well,
The front lights.
Oh gosh.
Oh, well, that works. Get the backlight so everybody can still see.
at the front.
What is going on?
Technology with lights, it's fine. Okay.
Describe me. What would it be?
There's no
insane.
I think it shorted out. I'm pretty sure it shorted out because it's now not it's not reading that there's any power there.
Did you break it?
Did you break it? Like a ceramic?
I may have broke it like a ceramic.
Spoof.
Okay.
Explain what happened.
Explain what happened. I went to put this into the plug. The plug shorted out. Now the plug is registering no amperage, and this thing cannot function, so we cannot break it this wire.
Boom.
And there was a bright blue light.
Boom.
And there was a bright blue light, that was the sparky.
Boom.
Boom.
Science is explosive.
Yeah, it can be, it doesn't have to be, yep.